Hi everyone, welcome back. In this video, we're going to talk about Ggplot for visualization. In previous modules, we've talked about visualization using R, but Ggplot is a very popular package in R for doing data visualizations, and it has some advantages over base R plotting. Now we can do, as we saw, we can make publication quality figures using base R, but it can take a lot of work to tweak the parameters. There's so many parameters, and the default plot doesn't have a legend and that kind of thing. So it's to add complexity to base R plots, we have to know a lot, and we have to really tweak the parameters quite a bit. In Ggplot, it gives us a very different framework for data visualization, and it has advantages that the defaults can often be more informative, and we can make plots very quickly that contain a lot of useful information. We can do data exploration in ways that we really can't do in base R, and many people find, once they understand the Ggplot syntax, that it's more intuitive. So we're going to take a look at it. Just at the up front, I'd like to say that I'm not a Ggplot expert, so we're going to go pretty fast. I wouldn't use this video as a be-all and end-all. Use the many resources that are out there to learn more about Ggplot. There's a great cheat sheet, so if you Google Ggplot cheat sheet, you'll find a ton of information, much of which we're not going to talk about in this video. And before we start, I want to thank Stephanie Freund, who put this module together originally. Thanks so much, Stephanie. Okay, let's get started. So, like every module in this bootcamp, you can click on this script, right-click or command-click, and just save it to your working directory so that we can pick up in RStudio and work through the code. All right. Before we do that, let's just do a quick intro to Ggplot 2. It's an R package. It's not part of base R. It was developed by Hadley Wickham, who also developed the tidyverse. All right. Ggplot in particular is based on work by Leland Wilkinson and others on the grammar of graphics. Ggplot does have a very peculiar grammar. It may not make sense at first, but again, a lot of people find it very intuitive. We'll talk about it, but Ggplot is modular. It is a little bit like that pipe operator in the tidyverse, where you can just keep on adding things to a command and basically add layers, in this case, to a plot. If you want to learn more about the grammar of graphics, you can click on this link. And if you want to learn about how that grammar was translated by Hadley Wickham into the Ggplot package, and learn a little bit about the basic syntax of Ggplot, click on this link. This is a really good read, not very long, and is a really good basic intro to the Ggplot package. All right. So before we move into RStudio, let's quickly go through a typical workflow in Ggplot. The first command or function call that you will see is this Ggplot, often with an open-close parenthesis, just specifying that you want to begin a Ggplot visualization. And then you can add to that. So you can add geometries. So you might add a box plot to your basic plotting device. You can overlay multiple different types of geometries. You can add a scatter plot using the point geometry. And when you want to specify how data are mapped to different parts of the visualization, say if you want to specify which data should be representing the x coordinates or the y coordinates on a Cartesian coordinate system, or say you want to specify the height of a bar plot, or say you want to specify the size of points in a scatter plot, you use the AES function, which is specifically designed to map the aesthetics, so map data to particular aesthetics of the plot. This hopefully will become clear. This is one of those, grammatical elements of Ggplot that, is intuitive once you get to know Ggplot, but is not intuitive when you first start. So the AES stands for aesthetics, and it's really for aesthetic mapping. So every time you see this, you will be mapping particular data to a particular type of the visualization, whether it's the coordinate or the size of points or height of bar plots, well, that kind of thing. So that is the basics of Ggplot. We'll go through several examples of how this is used. Obviously, it doesn't make sense quite yet, so don't be afraid if you don't get it yet. We're going to use the soils data set from the car data package in R as the main data set that we're going to visualize here. This data set contains soil attributes from a Gilgai landscape, which is just depressions in the landscape that can fill with water, and the depressions are caused by shrinking and swelling of clays. All right, and this is from Australia. So before we get started, make sure you install all these packages onto in your laptop or desktop. So we're going to need a bunch of packages. Obviously, we're going to need Ggplot 2. That's the main plotting workhorse that we're going to use here. Make sure you also have the tidyverse, Gg themes, car data, which is where we're going to get the Gilgai data, get the DAG, DAAG package, rcolor Brewer, and Leaflet package, because we're going to do a little demo at the end with Leaflet, which is an interactive mapping package. All right, so let's move into RStudio and get started. So here we are, module 2.3, 2_3.r, and let's load up the packages so we can take advantage of all this new functionality. All right, and let's load up the data. So we're going to get this car data. Actually, I don't know about you, but my my workspace is a little crowded here. So let's get rid of all these objects using remove everything in our environment, so that now when we load up the data, we can see that we have the soils data now, and we can look at it. So now we have this data frame version of soils and of the background soils data. So we can look at it up here and see the different data types and what we've got to work with. We've got a bunch of nutrients in the soil. Contour just represents something about that Gilgai landscape, depression, slope, etc. It's a categorical or a factor variable. So just take a minute to look at those measurements, and we can look at them this way using the head function. And let's make our first Ggplot visualization. We're going to do a bar plot, or sorry, a box plot, box and whisker plot. So we're going to run the Ggplot function. We give it a data set, all right? And so, another way to do that would be to specify data equals soil. And then we use this plus sign. That means we're going to add some more information to this plot. We're going to add a layer to the plot in this case, and the layer is going to be a box plot. So we're going to do this. We're going to start a Ggplot, which doesn't specify what we want to visualize or anything. And then we're going to specify that we want to add a box plot, a box and whiskers plot to this graphics device, and we're going to use this aesthetic mapping. And the aesthetic mapping is going to take some of the data, and it's going to say, okay, this is how I want to visualize this data. So it's going to take data, obviously, from the soil data frame, and the x coordinate is going of our new visualization is going to be specified by the contour variable. And the contour variable, remember, is a factor variable. So there's only, I think, 3 factors in that contour variable. So that's going to be represented on the x-axis as 3 different box plots or box and whisker figures. And the y coordinate basically represents the data we want to visualize as a box and whisker plot, and that's going to be the pH. So we're going to visualize the pH, basically the distribution of pH, the mean and the interquartile range for each of the contour factors. So let's look at what that looks like. So we have 3 different factors in the contour variable: the depression, slope, and top. And we're going to just visually assess if there's any differences between the pH of these different contour factors. And we see that it looks somewhat similar. Maybe the median's a bit lower for the top contour versus the depression and the slope. But obviously we didn't do a statistical test here. So this is just a basic visualization of our data. And like I said, Ggplot provides some really nice ways to do quick and dirty visualizations. And I shouldn't say dirty because they actually look fairly good, but they're really easy to run and they're informative. So it's a great way to do data exploration. Let's do a scatter plot in Ggplot. So let's take, again, the soils data. And this time we're going to add a point geometry, which means scatter plot. So basically points in an XY Cartesian coordinate system, and the X coordinate is going to be specified by the pH. So it's going to be the x-axis, and the Y coordinate is going to be specified by the calcium content. So we're going to look at calcium versus pH, calcium on the y-axis, pH on the x-axis. Let's look at that, and we see that the defaults look fairly nice. Unlike base R, there's kind of like these lines representing the coordinates. So you can like it or not, but that's the default. And you know, it just looks a little different. But here's our basic scatter plot. Now we don't just have to visualize points. We can add more information. We can change the size of the points according to some other column of data. We can change the color of the points, so on and so forth. So let's add a color, and the color is now going to be mapped with depth. And so different colors mapped to different depths, and that's what this aesthetic, the color aesthetic, is going to do. So it's going to map the color aspect to depth. So let's run that, and it'll automatically, and this is one of those nice things about Ggplot, it'll automatically give us a legend. We don't have to add the legend like we did with base R plotting. It just automatically knows that since we're mapping color with depth, we're going to want a legend. And so it gives us a default legend, which is pretty cool. So again, makes it a little easier on us. The defaults are more intuitive, more informative. All right. Note that if you wanted to change the color of all the points, you don't use the aesthetic. That's the Aes function is only for mapping data with particular visual aspects or particular aspects of this visualization, like color or coordinate or something like that. If you just want to make all the points red, you do it outside the aesthetic argument. So say you wanted to just make all the points red, right? But it's not mapped to any data. So we're going to get rid of the color here. And now we say color equals red. And we should see that all the points now are red. So do the color or other aspects, the size of the points, anything that's not actually mapping to a particular data, like the size doesn't represent any meaningful aspect of the data in each point. It's just, you know, overall visualization aspects. Do that outside of the Aes function. All right, we can see that here. where we can change the size and the stroke, meaning the border of each point. So we're going to make a thicker border and make large points, and we can change the shape and the color, obviously. So we can do a lot of we can, just like base R, we change a lot of the aspects of the plotting using these arguments. Some of them are a little different than base R, but let's run that, and now we can see we got big plots with a border and different colors representing depth, but all these other aspects are affecting all the points equally. All right, anything outside of the AES argument or function is being applied equally to all the points. All right, let's say we want to go ahead and add some more relationships to this plot. So we're visualizing currently calcium versus pH, but there's a bunch of other nutrients that are in this data set, and we might want to visualize the relationship with other nutrients and pH in this study system. All right, so we can maybe want to visualize not just calcium, but magnesium and sodium as well. So let's look at one way of doing this in the ggplot universe, and then we'll show why that's not so great, and then we'll move on to some better ways to do it. So what we're going to do is add this geom point. We're going to basically add 3 scatter plots. Each one of those scatter plots is going to have the pH on the x-axis. Now, if you notice above here, we see that the original ggplot function call just includes the data set. We could again say data equals soil, but that's all you have. And then the aesthetics are all put within the geom point. But if we want the pH to always be on the x-axis, we can actually specify the aesthetics within the original ggplot. That means that every single plot we make, or every single layer we add to this ggplot, is going to have pH by default be representing the x-coordinate. All right, so we're going to add aesthetics to the main ggplot call here, which makes it the default for all the subsequent layers that are then added to our plot. So we're going to do that. So we'll first specify that pH is always going to be the x-axis. Then we specify in each of these scatterplot layer calls, where we're adding scatterplots to the ggplot, we're going to add a new aesthetic that's going to specify which variable is going to map to the y-coordinate. And we're going to have 3 different variables: calcium, magnesium, and sodium, each in sequence being used as the y-coordinate. So ultimately, when we run all of this, we'll have we'll have 3 different scatter plots, essentially, all on top of each other. We're going to color them all black in the outline. So they're all going to have a black outline, but the fill color, that is the color inside the outline in each of these points, is going to be different colors. So one's going to be red, calcium's going to be red, magnesium's going to be blue, and sodium. And again, that's sodium and not Na for not Na like that, but sodium. And so we're going to, again, use this circular shape with a different fill color, and we're going to do it 3 different times. So when we run this, we should see basically 3 scatter plots overlaid on top of one another. So red is calcium, the blues are magnesium, and the grays are sodium. What is missing here in this plot? Well, the most obvious thing is probably the legend, because we can't really interpret this without going back to the code. So in this case, ggplot didn't automatically put a legend in. It just puts 3 scatter plots. We could force ggplot to give us a good legend and everything, but here the defaults of ggplot aren't really playing very nicely with what we want, and we can use some other tricks to get ggplot to do really what we want in a simpler way. So let's abandon this. Hopefully that made sense to you, what we just did. But now we're going to do a different way of visualizing all 3 of these different relationships on the same plot, but also making it look nicer and harnessing ggplot's ggplot's really nice defaults. All right. So the first thing we have to do is to use a tidyverse trick, which we learned in the last video. It's called pivot longer, which takes several columns and then just instead of making them columns, we're going to make separate rows for every one of those columns for every observation. So for every observation, we're now going to have, for every observation in the original data frame, we're going to have several observations, one for each of the rows that we're going to pivot. So we're going to pivot those rows or pivot those columns into new rows. Okay, so what we're going to do is use pivot longer. We're going to take the original soils data frame, and we're going to pivot these columns, calcium, magnesium, and sodium, so that those columns now become rows. So for every observation, we have 3 new observations, one for calcium, one for magnesium, one for sodium. And the name of we're going to have 2 new columns, one representing calcium, magnesium, and sodium. We're going to call that nutrient. So the nutrient column is going to contain the label calcium for the calcium observation, so on and so forth. And then we're going to have another column called value, which represents whatever the value was in the original data frame for each of those columns. So now we're going to move those into rows, and so if the nutrient column says calcium, value is going to be the value for the calcium. And so let's do that, and so that that's the first step we need to do in order to make this visualization work. And then we're going to take this new data frame or tibble that we just made, and we're going to make that the data that we're going to be using for this visualization. We're going to add G on point to specify we want a scatter plot, and the aesthetics are going to be mapped like this. So X coordinate is going to be specified by pH. The Y coordinate is going to be specified by the new value column, right? So that represents calcium, magnesium, and sodium, right? And then we're going to make the fill color, the color of the fill, related to nutrient. So we're going to map the nutrient factor, which is just 3 different factors, calcium, magnesium, and sodium. We're going to map that to color, and that we're basically telling ggplot we want that. It's going to specify those colors by default. We could specify them manually. We're going to specify all these outside the aesthetic function because they affect all points equally. And let's look at what it does. So it basically does the same thing that we just did. We have, different points colored by nutrient, but now it gives us a nice legend by default. So this is just a nicer way to do what we were trying to do up here. Obviously easier, fewer lines of code, and it gives us better defaults. So just something good to know when using ggplot. All right. What if we wanted to plot a different nutrient? Instead of sodium, we're going to plot potassium instead. So let's look at what that does. We're going to do the exact same thing we did before. We're going to make another soil nutrient tibble or data frame using the pivot longer, and we're going to pivot those columns into new rows, and we're going to make 2 new columns, nutrient and value. And so we run that, and again, if you want to look at it, you could see what it looks like. We have 2 new columns, nutrient and value, and for every observation we now have, in the original data set, we now have 3 new observations for calcium, magnesium, and potassium. All right, and all the rest of the columns are just duplicated for each of those. So that's was formerly 1 row, now it's 3 rows. All right, so let's run the ggplot. We have the soil nutrient 2. Soil nutrient 2 is the one we just made, is going to be the base data for this plot, and we're going to do the same thing we did before. So X coordinates representing pH, Y representing value, or value representing the Y, and then the color fill will be represented by the nutrient, and it'll look the same, except look at the calcium. The calcium's kind of on a different order of magnitude, so this plot is less informative now because they're not all kind of on the same scale, right? So there's different scales here. Potassium's on a totally different scale than calcium and magnesium, so it just doesn't look really good. So let's look at some new aspects of Ggplot that can help us with this. So we're going to look at facets. Facets, a similar way that we were talking about multi-panel figures in the base R module. It's the same thing. It's just putting multiple panels next to each other in an informative way to basically add more information to a figure. So we're also going to talk about scales. Clearly, we have a scale issue here, and themes. So there are different Ggplot themes we can use with different defaults for the color scheme and things like that. So good to know about and fun to play with. You can find one you really like and then use that theme over and over again. And again, can make it much easier to make nice figures just the way you want them. So let's look at this much more complex Ggplot call. So we're going to call Ggplot now with the soil nutrient 2 data set with calcium, potassium, and magnesium. All right, we're going to make a scatter plot, and just like we did before with the x mapped to pH, the pH values mapping to the x coordinate of the plot, the value column representing the y coordinate, and the nutrient describing the color or the fill. All right, and we're going to then add this Facet Wrap command, which will add different plots, this time different plots for each nutrient. So we're going to have not just calcium, potassium, magnesium in the same plot, but we're going to have 3 plots. So we're going to do this Facet Wrap to make a different plot for every nutrient. And we're going to use that tilde to say that's the syntax that it expects, so that we know that nutrient is going to define the panels or the facets of this new plot. And for every plot, we have to specify whether we want the scale to be constant, like the y-axis scale and the x-axis scale to be constant across these panels, or we want them to be changing relative to whatever is being mapped. So if it, if in this case we're looking at calcium and potassium, or calcium and magnesium being up here and potassium being down here, now we probably want the y scale to be free to vary depending on the actual scale of measurement of each of these nutrients. And so we're probably going to want them to be different, because otherwise we're going to see the same thing, that the potassium is just way down here and we barely see any information because it's all kind of like squished into the x-axis. So we want to be able to let that y scale vary depending on nutrient. That's what it's saying here. So by saying free underscore y, we're allowing the y coordinate to, or the y-axis scale to differ among the 3 panels that we're going to create for each nutrient. We're going to add an informative y-axis label so we know what the units are in this case, and it's going to be milligrams per 100 grams of soil. That's the units that these are measured in. We're going to add a theme, and the theme is going to be the black and white theme. So theme underscore black and white, and we're to make that, to apply that function, because it is a function, we have to add the open close parentheses, and then finally we're going to change the theme. So the theme function will allow us to tweak the theme, and in this case we're going to add a call that says we don't want any legend, because that would be redundant, because we don't really need a legend. We're going to have each panel is going to be labeled with the nutrients, so that's the main thing we need. So we don't actually need a legend for every single one of these panels. We're going to add an axis title or axis text, and the axis text just means this text here, that's the axis text. We can specify the size of the text. We can specify the size of the axis title text. That's this text here. and we can specify the strip text, and that's going to be at the top of each panel. It's going to be kind of a strip with a darker gray background that's going to have the labels according to whatever we defined here, and here it's going to be by nutrients. But whatever we're using to specify the panels or the facets, that's what's going to be automatically by default put as these strip labels, and we can specify that we want a bold text and a large text for the strip labels. So that's what we're doing here. And again, if you don't feel like you need to memorize any of this, this is all going to be in that cheat sheet. If you want to download that, Google Ggplot cheat sheet, and you can learn more about how this all works. But here's a facet plot in Ggplot. Each panel is a different nutrient, and now you can see that the y-axis scale is varying for each of these plots, and it gives us a much more informative look at the relationship between pH and potassium than we had before, where potassium was way against the x-axis. And we did that by using scales equals free y up here. All right, so looking pretty good. This is a much nicer looking figure than what we had before. So we can, obviously there's a lot more we can change in these figures, and one of the ways is to use different color palettes. It's kind of cool to play with different color palettes and see which ones convey the information you want to convey in the best way. Color Brewer is a really commonly or popular package that gives you a bunch of really nice color palettes. So if you want to look at the color palettes that the Brewer package gives you, you can look at that here, and it'll be, maybe you zoom in, you get a better view of that. So you can pick and choose what you like here, or what best represents the system or the information you're trying to represent. All right, let's go back, give ourselves a little room here, and let's use the Color Brewer package and change some visualization. So we're going to again use the soil data. We're going to add scatter plot. Now the key difference here is that we're now going to use color, the fill color of the different points. That we're going to, the color is now going to represent depth, all right? And that fill color is going to be drawn from the Brewer palette. So the soil depth is going to be represented by the Brewer palette, and we're going to choose this particular palette in the Brewer package, YL or BR, so yellow to brown. And if we zoom in, we can see what it's going to be. This palette we're going to choose to represent soil depth, and it does kind of look a little soil colored, I guess, so that would be a good choice here. And we're also going to provide a name for the legend that's going to appear that links the soil depth to color in the so we are going to include a legend here. We're not suppressing any legends in this case. And let's look at what happens here. So we get a plot, a scatter plot, where the color represents soil depth, and it's doing it in a nice way. And the darker colors, the brown colors represent deep soil, and the lighter or yellow colors represent more shallow soil. And we can see where these points fall out within this pH and calcium scatter plot. So in the deeper soils tend to have lower pH and lower calcium. So it's giving us a lot of information, and it's doing it in a way that's very interpretable and easy to look at. So which is what Ggplot is good for, and why so many people like to use it. You don't have to use our Color Brewer package. You can make your own color palettes if you want. Again, tons of flexibility. We're just really literally scratching the surface here, but tons of flexibility. Here you're specifying your own set of colors that you want to use. And if you want to learn more, there's some links in the web page if you want to learn more about different colors. Here, let's that's the themes, specifying colors. Here's our color Brewer. But if you want to specify your own, you can go down here and oh, that's a dead link. But if you want to find colors really quickly using these hex codes that we're using in this example, you can find a color that you like and find the hex code that that would specify that color. So you can use something like this website to give you to find hex codes that work for you, and you can manually make a palette that looks good to you. So fun thing to play around with. So again, here we go. Here's the hex codes that we chose in advance for this exercise, and we're going to do the same thing but just with a different color palette. So these are colors that we chose to represent soil depth, and maybe it's better, maybe it's not, but again, you can play with it and make the figure look exactly the way you want it to look. A couple other things we can do with Ggplot. We can add spline fits, like smooth regression fits. There's a lot of different stats we can add to our figures. So let's play around with trend lines, because it's a popular and common thing you might want to add to a scatter plot, for instance. So let's make the scatter plot. We're going to, again, kind of do the same thing we've done, where the fill is now, the color is going to be mapped to nutrient. Now, we're going to do the facet wrap, so we're going to have 3 different plots side by side, 1 plot for each nutrient. Each plot is going to have a free y-axis, and we're going to add this smooth geometry. So this is not going to add a scatter plot, but it's going to add a trend line, and the trend line is going to be a linear model, so that this is, remember the LM for linear model we went through in the base R stats part of this R bootcamp. Well, we're going to use that to define the trend line. All right, and the trend line is going to be black, and the trend line is going to be defined as, whatever the value is for that facet. So whatever nutrient that panel represents is going to be on the y-axis, and the pH is going to be on the x-axis. And it's going to do a regression, basically, of the value or the nutrient versus pH, and it's going to add that to our existing plot. We're going to add an informative y-axis. We're going to use the black and white theme, and we can make these adjustments to the theme. All right. So there we go. We have the same figure we had before, but now we have these linear trend lines based on the LM function in base R. It's going to do a regression, and it's even by default, which is very cool, giving us standard error bars on our regression line. So useful defaults is what makes Ggplot so nice in many cases. All right, we can do the same thing kind of with histograms. Histograms, again, a really common kind of visualization that we might want to do. We're going to take the soil nutrient data set, and instead of adding a scatter plot this time, we're going to, which is geom_point for a scatter plot. For a histogram, we can use geom_histogram to add a histogram. And we just specify what variable we want to do a histogram for, and that's going to be the value column. And that we're going to have a separate panel, or we're going to make 3 histograms side by side, one representing each nutrient. So we're going to let the y and the x-axis, by saying scales equals free, we're going to let the y and x-axis be free for each panel, so that we capture the full range of data. And we're going to label the x-axis with the appropriate units that is represented by this value column. And we're going to use a different theme. This time we're going to use the dark theme. And again, it's kind of a fun thing to play with. Maybe you could try different themes and see what they look like. And we're going to change the theme just by changing the size of the lettering for the axis labels and stuff like that. So that's what we're going to do. 3 histograms side by side, representing one for each nutrient here. And the scale is going to vary by each panel. Is the x-axis is varying totally freely. So we have a nice axis label and so on and so forth. I'm not sure I love the dark theme, but again, you could play with other themes and see what it looks like. We might want to add some density curves on top of these histograms. It's a common thing to do. It might be to look at a kernel density, just to sort of look at a smoothed version of a histogram, or we might overlay a normal distribution to see how closely these distributions match with a normal distribution. So let's look at that. So we're going to make the same figure, but this time we're going to add this geom density. We're going to add a density plot or density curve to each of these histograms, and the density curve is going to be colored differently for each nutrient, and the density curve is going to have the same x, it's representing the amount of nutrient basically. So it's the same thing as up here, so that we're going to make the density curve using the same data as we used to build the histogram originally. That's right here. So these are the same data. Oops. And we're going to make we're going to make the line a little bit thicker than the default, so size equals 1.5. Separate panel for each histogram, so on and so forth. So everything else is the same. Let's run that, and now you see we have these kernel density curves sort of providing a smoothed version of the histogram for each. You'll notice that there is something we added up here, y equals ... density ... There are some internal functions that Ggplot allows you to use, and what this is doing is, instead of saying that we count up the total number of observations in each of these bins like a standard histogram, we're going to rescale that. Instead of count, we're going to do it in terms of density. And so that's, we're going to rescale the y-axis in terms of density. That's what we're doing right here. And density is anytime you see the double ... density ... or any other thing between these two dots. It's an internal command that Ggplot's going to recognize that allows you to do certain things, like with this histogram, to change from the count like this to density on the y-axis. All right. That's all that we want to go through with this figure. Let's, instead of using the kernel density representations here, let's use a normal distribution instead. So this time we're going to add a normal distribution, a normal curve on top of these histograms to see how well these histograms match with the normal distribution. So again, everything else is fine. Everything else is the same as we've done previously, except for this stat function. So this is a convenience function for adding things like known probability distributions to a curve, to a Ggplot that already exists. So we're going to, in this case, use dnorm. So this is similar to the curve function in base R for adding, for visualizing the output of a function across a range of values. Here we're going to visualize dnorm. And dnorm is a base R function. To say I want to get the probability density of a normal distribution at let's say 6 from a normal distribution with a mean of 10 and a standard deviation of 5, and that gives us the density of 0.057. So it's like, and if you wanted to plot out or use the curve function to do a similar thing in base R, you could say dnorm x 10, 5, and let's visualize it from 0 to 20, and we can see this normal distribution just using the curve function. Gives you the probability density, d norm, under the normal distribution with a mean of 10 and a standard deviation of 5, and it just varies across this whole range from 0 to 20, all right? And you could see what it evaluated at 6 was 0.0579, so right here, this is 0.0579. You can see that's about right. So that's how d norm works. That's a little aside there. But again, we're harnessing a base R function here, and we're just adding it to the plot. We're going to color it blue. We're going to make the line width a little thicker. And we're going to use the dnorm function where the mean is equal to the mean value of whatever the column that we are using is. So in this case, the value column, we're just going to do a normal distribution with that mean, the observed mean, the sample mean, and the sample standard deviation. We'll just overlay that normal distribution that has the same mean and standard deviation as the histogram we're representing, and just overlay it and see how well it matches with the observed data. All right, everything else looks the same, so let's make this figure. So we have these thick blue lines representing the normal probability density, and we see that they're, maybe some reason to think that these data are not perfectly normally distributed, but we might want to do a test beyond that. All right, now before we move on to the leaflet mapping and then to the challenge problems beyond that, let's play around with error bars, because there's, and again, something that we want to do all the time with plotting. So we're going to make a box plot. Now, if you recall, the original box plot we did didn't have any width to the ends of the whiskers. So the whiskers were just lines. If you know, in base R, the default is to have caps on the whiskers. So it's, again, a matter of your preference, but if you wanted to put caps on the whiskers in Ggplot, you can do that. You just have to alter the default. So in this case, we're doing the box plot, but we are, and by saying stat box plot, we're actually computing the stats for the box plot, and the error bars are going to have a width of 0.2. So by specifying the width, it's going to actually put caps on the error bars. Then we're going to add the box plot, and the box plot's going to have the contour be the variable, the categorical variable. For every contour level, we're going to have a different box and whisker, and it's going to, the box and whiskers are going to represent pH. So that's what's going to happen when we add the box plot. And now we can also, just for fun, we can add the mean as well. So we'll add a stat summary where we're going to basically specify that we want to generate the mean value for every one of these boxes, and we're going to add the mean as a point. So it's going to be a point, it's going to be a large dot, and it's going to have a black color. So we're going to add a black dot representing the mean on top of our existing box and whisker plots. All right, and let's add that, and we see that indeed we have box and whisker plots that look a little more like the base R version of box and whisker plots with these caps, and we've added points representing the mean. So we have the median, represented already within the box and whisker plots right here, and then the mean as well. So again, we can flexibly change these elements, often fairly easily, but we have to know the syntax, and the cheat sheet's a good first place. Use the help documentation within R, and you can figure out how the syntax works for changing some of these graphical elements. All right, last thing we want to do before we move on to the challenge problems is to use Leaflet. Leaflet is a fancy interactive mapping function for R. So we just give some coordinates, that kind of thing, And then Leaflet makes it really easy to plot those coordinates on a map and add different layers to the map, and even make that map interactive, so you can zoom in on different features and zoom out, and you know, add different layers to the map or interactively and that kind of thing. So Leaflet's really cool. What we're going to do is we're going to take this Possum Sites data. Let's see, do we have this data? Yep, so it's already loaded in one of the packages we already loaded. If you want to, let's learn more about it real quick. It's something to do with the locations and altitude of all these different possum observations in maybe Australia. Let's look at that. Possum sites. So yeah, possum sites consist of longitude, latitude, and altitude for the 7 sites from southern Victoria where so these are the sites where the possum observations were made. So 7 different longitude and latitude and altitude for these different sites. All right. So the first thing we're going to do is add tiles, meaning we're going to add a base map, which is by default adds tiles from the OpenStreetMap database. So it's going to download basic information for these locations. We're going to specify the so we're going to add markers. That's basically going to add kind of waypoints on this map. And the longitude and latitude are specified by this Possum Sites data set. And the pop-up, that is, if you scroll over these points, it'll show what their altitude is. All right, let's look at what this does. So let's run this leaflet, and we see that all of a sudden, since we gave it these coordinates, it's just by default going to zoom out to an extent that includes all of these sites, these 6 sites, I believe, where possum data were collected. But if you want, you can zoom out. You can use the scroll bar, or just you know, use these. You can just zoom in, and if you click on any of these sites, it gives you the elevation. So again, just a really brief intro. Totally something to play with. It's very cool. So with that, I would encourage you to go on and try the challenge problems. And as always, let me know if you have any questions. And I'll see you in the next video.